So in part 4 of this series, we combined mirror with an n-fold rotation axis, and that gave us 4 new point groups mm2, 3m, 4mm and 6mm. We will now try to do this same exercise, repeat this exercise by trying to combine a mirror parallel to an n bar axis, to an n-fold roto-inversion axis. Crystallographically, 6 roto-inversion axes are allowed. However, 1 bar and 2 bar are special cases. 1 bar is a center of inversion and 2 bar is a mirror plane perpendicular to the 2 bar axis. However, we will take these special cases also, and of course, in 1 bar case, parallel or perpendicular also makes really no sense, because 1 bar is just a center of inversion. However, we will still see what is the result of combining a mirror plane to a center of inversion. The resulting groups, let me just list. The resulting group of combining 1 bar with a mirror is 2 by m, 2 bar with a mirror is mm2, 3 bar with mirror is 3 bar m, 4 bar with mirror is 4 bar m2, and finally with 6 bar m2. The corresponding Schoenflies symbols are, as we know, C2 with a horizontal mirror, C2 with a vertical mirror, D3 with diagonal mirrors, D2 with diagonal mirrors, and D3 with horizontal mirrors. So, these two, the first two cases we have already handled in our previous development by a different way. 2 by m we considered as combination of a mirror plane perpendicular to two-fold axis, whereas mm2 we looked at as mirror plane parallel to the two-fold axis. So, these two groups we have seen before. 2 by m we met when we combined a mirror plane perpendicular to a two-fold axis. That was in part 8 of this series, and mm2 we did as mirror plane parallel to two-fold axis in part 7 of this series. So, essentially 3 new groups will be developed in this video, and those are with respect to the 3 bar, 4 bar and 6 bar axes, 3 bar m, 4 bar m2 and 6 bar m2. However, let us first look at what is the resultant of a mirror and an inversion center lying on the mirror plane. So, let us take a mirror. So, we take a horizontal mirror along the primitive and we put a center of inversion in the center. So, the mirror will reflect a general position above the equatorial plane into an object of changed handedness below the mirror plane. Now, if we invert these, so then the black point after inversion will go down and change handedness. So, it will again become a open red circle, and the open red circle after inversion will come up and change its handedness. So, will become a black point. So, you can see that the combination of these two then is giving you, if you see now the relate the two black points, so there is no change in handedness, but there is a rotation by 180 degree, and the same thing is true for the red one, no change in handedness, and a rotation by 180 degree. So, rotation by 180 degree is part of the symmetry in this case. So, we really have a two-fold axis in the center. There is a perpendicular two-fold axis. So, we can write this in the equation form that m plus 1 bar is a perpendicular, is a two-fold, we can say a two-fold perpendicular to m. So, this is an important result, and the point group, as you can see, we have two-fold perpendicular to m. So, this is what will be called a point group 2 by m, or in Schoenflies notation C2 with a horizontal mirror. So, that is nothing new, we have done that, but we have now obtained the same thing by combination of a mirror plane and center of inversion. Now, the other so called, means I will say a trivial case, is trying to put mirror parallel to a 2 bar. So, a 2 bar axis has been put in the center. 2 bar, since it is 2 bar, we have seen in part 6 that 2 bar is equivalent to a mirror plane, and that mirror plane is perpendicular to the 2 bar axis. So, if 2 bar axis is shown in the center of the primitive circle itself is the mirror plane corresponding to that 2 bar. So, which means if I have a general object, a general position shown in black here, that will be reflected by the mirror plane, or you can say it has been rotated by the 2 bar axis into a chain handedness below the equatorial plane. So, that is 2 bar. Now, we are demanding that we will put an m parallel to 2 bar. 2 bar is passing through the center of the primitive. So, m parallel to 2 bar will be a diameter, a vertical mirror plane passing through the center of the primitive. If we do this, and if we now apply this to the two existing objects which we have, two existing general position, black point will become a red point on the other side of the mirror, and the red open circle will become a black open circle on the other side of the mirror. Now, these 4 points complete the group, but you can see here that we now have two mirror planes perpendicular to each other, because there is a horizontal mirror plane and a vertical mirror plane. So, the horizontal line of intersection of these two, whenever two perpendicular mirror planes intersect, we have seen they give you a two-fold axis in the line of intersection. So, this is a two-fold axis. So, really what we have got in this group is a two-fold axis with two perpendicular mirrors passing through this. You can remember that this is the point group which we call MM2, two mirrors intersecting and giving a two-fold axis. Only this stereogram is in a non-standard stereogram, because two-fold is now a horizontal direction, two-fold is lying on the primitive. We usually draw the stereogram, the standard stereogram for this point group. We draw it with the two-fold in the center. Sorry, I should not draw now. If I rotate that, the primitive will no more be a mirror plane. So, I draw the primitive in blue. I bring the two-fold in the center, vertical two-fold, and two mirror planes passing through the two-fold. So, this is the standard representation of MM2, but these are just two different orientations of the stereogram. The point group is the same. So, we can say that M parallel to 2 bar gives us a point group, or we can write it this way, that a 2 bar plus a parallel mirror with nothing but MM2. So, these 2 point groups, these our exercise made us more familiar and understand better these point groups, but didn't give us any new point groups. New point groups will start emerging when we continue this exercise with 3 bar, 4 bar and 6 bar. Let us now look at combination of a mirror plane perpendicular to 3 bar axis. We have met 3 bar in part 6, where we also saw that 3 bar was nothing but a combination of 3-fold axis and an inversion center. So, this stereogram was generated there, had 6 general position, 3 of right handedness and 3 of left handed objects. So, the group operations are 1, 3 plus and 3 minus, that relates to the 3-fold axis, and the 1 bar, 3 bar plus and 3 bar minus, which results with combination of 1 bar. Our job now is to add a mirror plane to this point group, a parallel mirror plane. So, let us make one of these reference lines the mirror plane. Now, when we develop the point group 3 mm in part 7, then we know that from that analysis there that a single mirror plane added parallel to a 3-fold axis generates 2 other mirror planes which are at 60 degrees. So, let us add these mirror planes. So, now I have 3 mirror planes, and these mirror planes will reflect the existing general positions into new positions to generate more equivalent positions. So, the left handed objects will now reflect into the right handed object will now reflect into left handed object, and the left handed objects will reflect into right handed objects due to the presence of these mirrors. Now, notice that some new symmetry operations have generated. What are they? So, for example, this black dot is related to this black dot above the equatorial plane is related to this black circle below the equatorial plane, and it can be taken there by a 2-fold rotation located there. Of course, not just these 2 points, you can see is applicable to all other pairs of point. Everywhere this 2-fold axis acts and images any given object into its corresponding image. So, you have a 2-fold axis. Again, when we developed the point group 3, 2, 2 as a dihedral group in part 3. So, from there you know that if you have a 2-fold perpendicular to a 3-fold axis, you will generate other 2 3-fold axes. In total, there will be 3 2-fold axes perpendicular to, that was a 3, 2, 2 dihedral group. And you can convince yourself from the general positions shown here that these are also 2-fold axes. So, now I have an interesting point group. It has become little too cluttered. So, let me try to make it little clean by removing these connecting lines. So, this is an interesting point group where you have a 3-fold axis, a center of inversion, 3 mirror planes passing through the 3-fold axis, and 3 2-fold axes perpendicular to the 3-fold axis, and the mirror and 2-fold axes are alternating. So, now I have 12 general positions. So, that means there are 12 operations. So, 6 operations of 3 bar will be there, other 6 operations is generated by the combination. So, those 6 operations are very simple here to see. They are the 3 mirrors and the 3 2-folds. I can label them by the standard convention. So, for that I need to know the directions. So if I call this direction, take this direction as my 1O direction, and at 120 degree the O1O direction, then this becomes the 110 direction, this becomes bar 110 direction. In the middle of 1O and 110 I have 210, and in the middle of 110 and 010 I have 120. So we have now labeled the directions. So we can now find the label for, or the designation for, the mirror planes and the two-fold axes. First let me write the two-fold axes. The two-fold axes are along bar 110, then along 210 and along 120. So I have three two-fold axes, and if you look at mirror, and mirrors are supposed to be designated by perpendicular directions, and if you see there is a mirror, this mirror is exactly perpendicular to the two-fold axis bar 110. So actually mirrors are also, the normals of the mirrors are along the same direction as the two-fold. So I can write M bar 110, M210 and M120. So to complete my group of order 12. Let us now put M parallel to 4 bar, M parallel to 4 bar. So 4 bar group is shown here. It has 4 operations, 1, 4 plus, 2 and 4 minus, and all these operations are about the vertical axis, the 0 0 1 axis. So this gives the 4 bar group. The histogram is shown with 2 points of same handedness above and 2 points of opposite handedness below the equatorial plane. So that was the 4 bar group which we have met before. Now our job is to add a mirror plane parallel to 4 bar. So I decide to place this mirror plane. As soon as I do that, there will be reflection due to the mirror plane, and I will start generating objects of opposite handedness due to reflection. So this completes the group, but you can see now that there are other symmetry operations which are appearing. So this vertical diagonal now is acting or representing another mirror plane, a mirror plane perpendicular to the original one which I added. So this mirror plane has appeared, and not only this mirror plane, if you see we have now two-fold axes in between the mirror planes exactly along the 45-degree lines. We have the two-fold axis, because these two-fold axes will relate object of same handedness, but by rotation by 180 degree about the horizontal direction. So I can quickly write the other operations which can be added to this. So we see that we have added two mirrors M10 and M010. This is the 10 direction. So mirror normal to this is called M10. This is 010 direction. Mirror normal to this will be called M010. And we have two new two folds which are in the direction bar 110 and 110. So that completes the group 4 bar M2. Finally, we try to put mirror plane parallel to a 6 bar axis. We have seen 6 bar in part 6, and there we also saw that 6 bar was equivalent to a 3-fold with a perpendicular. In fact, the Schoenflies notation for 6 bar is C3H, horizontal mirror. So, we have a 3-fold axis and a horizontal mirror. So, the 3 black dots are related to each other by 3-fold axis. Similarly, the 3 red circles are related by the 3-fold axis, but a black dot above the equatorial plane and a red circle below the equatorial plane, these two are related by the horizontal mirror shown as the primitive circle of this diagram. So, if we write the operations, so the 6 bar operations are shown here. We had developed it in part 6. So, the operations are identity 6 bar plus, 3 bar plus, 3 minus, 6 bar minus, and a mirror plane OO1. All these have the direction OO1. The rotation axes are OO1 and the normal to mirror plane is OO1. Now, we are going to add a parallel mirror. So, let me add a mirror. Let me try to be little careful in putting the mirror. So, I am calling this direction as my 1O, this direction is O10, this is 11O. So, let me put a mirror not along the 1O direction, but normal to 1O direction. So, then I will have to put mirror on this bisector line like this. So, this will be the 1OO mirror. So, I have added a 1OO mirror to my group. And what will be the effect of this 1OO mirror? Again, since 6 bar is 3 by m, 3-fold is part of 6 bar axis, which is shown also in its graphical symbol, where an open hexagon has a solid equilateral triangle inside it. So, and we have seen that if there is a mirror with 3-fold axis, then there will be 3 mirrors actually at 60 degree apart, and they can be drawn. They can be drawn like this. Don't forget your general result, that wherever 2 perpendicular mirrors intersect, you get a 2-fold axis. So, there is a horizontal mirror and a vertical mirror. So, 2-fold axes start emerging. We have not completed the equivalent positions. So, let us do that. So, a mirror will reflect the black open circle there into a red open circle there into a black open circle here, and then you will have another black open circle there, another black open circle there, and correspondingly the black dots will reflect into red dots inside these. So, now the group is complete. It is a group of order 12, as you can see, 12 general positions. So, 12 operations have to be written, 6 have been written, 7th is M1O. We have seen that 3 other mirrors got generated. So, I will write those mirrors by their normals. So, if the other normals are M010 and M110, and the 2 folds are along bar 11G, bar 110, 210 and 120. So I have two folds, bar 110, 210, 120. So with great hard work we have completed these three interesting point groups which result from combination of a mirror plane parallel to an n bar axis, a roto inversion axis, 3 bar m, 4 bar m2 and 6 bar m2. Note that in all these cases we added a mirror plane parallel to the threefold. For example, in this case we added a mirror plane parallel to threefold axis, but as a result we also got a twofold perpendicular to the threefold axis. So same result we would have got if instead of putting a mirror plane parallel to the threefold axis, we would have started by putting a twofold axis perpendicular to the n bar axis. Same case is here also. We put a mirror plane, but we got a perpendicular twofold in case of 4 bar and in case of 6 bar. So we can write this as a general result that the result of putting a mirror plane parallel to an n bar axis, you get the same group as if you will put a twofold perpendicular to n bar axis. With this, let us end this exercise. We will see you in the next video. Thank you very much.